Hello student, today I am going to demonstrate you about the magnetic levitation system. This is the magnetic levitation system what we have in our lab, in our data equation lab class. So I am going to demonstrate about this setup. So this is called electromagnet. Okay, and this is the plastic object inside a transparent cylinder, and here backside there is a scale, measuring scale. Means if you give some current to this electromagnet, the object will lift up and it will be like suspended in air, and you can control the levitation height. How it can be possible? By using a PD controller. This is a PD controller, and feedback we are taking from here. This is called Hall effect sensor. This one, Hall effect sensor. Okay. Now you can control the electromagnet current from this panel. This is the knob from where you can control the current. Okay, if you control the current accordingly, the object will lift up for say 1.11 voltage of the object will lift at 2 mm. And if you set the gain knob, this one gain knob, if you gain knob equal to is 2, then sensor voltage equal to 4.11. At that particular, in this particular setting, you can get a levitated height of 2 mm. Okay, for second set of reading, you need to rotate this knob of reference voltage and rotate the knob of gain. You can lift this object, magnetic object, again further say 5 mm in next reading. Then accordingly you can get two. This is magnetic current I and the sensor voltage V, and this one the plastic object distance is X. So this three value you can get from here. So like that way you need to take 5 different set of reading for this experiment. Okay, so now I am going to show you what will be the data set look like. So this is the data set. Okay, this is the data set where this electromagnet inductance is already given, this one. Okay, then your uh, magnetic inductance is given, magnetic resistance is given, mass of the object is given, then standard object distance is given x naught, then standard current is given. These data are given. Okay, now what we need to do, you need to take the 5 set of reading by adjusting different height, levitated height, and ampere current. Okay, so finally what you need to find, this average volt, average C. From here you can get x and I, and from x and I you can find this C value. Okay, C, L is already given, x you can get from here, so C value, then you can get 5 average C value. From 5 average C value you can put here in this K naught. Okay, from K naught you can get this C, average C value you can put here, then you can get the K naught value. Okay, x naught, I naught already given, L is given, mass of the object is given, then you can get K naught. Beta also you can get by that way, where in this formula into finding beta, the C is given. So C is you can take the average C value, I naught you can take from standard value, M you can take the mass of the object, and you can get x naught standard value. By that way you can fill this table. Okay, so how to take the data, I will go to show you one video about that. Okay, So if you change the magnetic current like this, the object will lift. Object will lift up. So different current setting, current and gain setting, your object will lift up. So one set of rating you can get this magnetic current I, this object height which will be taking from mid of the object to M, and sensor voltage. Sensor voltage is no need for calculation, only you need to magnetic current I value and X value, which will be measured from mid of the object to top of the magnet. Okay. So by that way you can fill this table. And all these soft copies of this experimental manual and data sheet, everything we will mail you. Okay. Thank you.